Okay, yeah. Hi everyone. So we are happily inviting you for this another session of AWS system design series. So in this session, we are going to discuss about uh, how to build the or how the social media the feed suggestion is actually working, and then how to build that, and what are the functional requirement, what are the non-functional requirement it has, and then what are the table design, database design, and then what are the APIs is really needed, and then what is key features, key issues it has, and then what are the uh, architectural diagram, so how it's internally functioning, what are the components it has. So everything we are going to discuss about in this session. So yeah, let's talk about the functional requirement. So in the functional requirement, we need like a user can create the post with text, images, and videos. They can do it, and then the user can follow and unfollow other users. Okay, user can see a feed or post from the followed users, and then posts are ranked based on the relevance, based on their engagement, like recency and personalizations, based on the preference. The post suggestions would be coming to their news feed, like our social media feed. Okay, and then user can like, comment, and share their post, and then real time updates we are expecting it, and then whatever the new post and interaction has been happening. Okay, and then it should be infinite scrolling for continuous feeds updates. So these are the functional requirements we can expect for when we are building the social media uh, application, which is like a Facebook or a Twitter or a LinkedIn, that uh, social media applications we can consider that. So and then what are the non-functional requirements we need? So which is like it should be very scalable. It should handle millions of users and post. It should be capable to scale it, and then latency is very very low. Expecting the feed should load less than 200 milliseconds, and then system should be highly available. System should not have any downtime. Okay, and then what is the trade-off? Like a consistency versus availability. This is the one of the trade-off we can see. Use eventual consistency to improve the performance. Okay, and then the security ensure the privacy and data protection. One thing like a consistency, there are two different consistencies there. One is a strong consistency, another one is eventual consistency. Strong consistency, what it will happen, like when there is a write happen to the specific instance or a specific server, it should be immediately at the same time, it should be replicated to other servers as well. So that is the strong consistency. Eventual consistency, what it will happen, like when there is a write, it happens, it we can expect it may have some delays to update the content in other servers. So that is the eventual consistency. To follow the eventual consistency, that will help us to improve the performance as well. Yeah, so security, ensure user privacy and data protection is really important, and then fault tolerance, like which is like a system should handle server failures gracefully. Okay, these are the non-functional requirements we should consider. Okay, and then what is the back of the envelope? Back of the envelope estimation means uh, how many users we are expecting they are going to be joined, they are going to be they are going to use our application. That is the back of envelope, the estimations. We can expect active users, daily active users, it would be around 500 millions. Let's take about any popular social media. So 500 million daily active users we can expect it. Okay, and then the post per day, like each users post 2 times per day. Okay, the when we calling that, then it will be 1 billion post per day. Okay, feed reads, how many read requests it's going to happen. Okay, so each user fetch feed 10 times per day. Okay, which means 5 billion reads per day. Okay, and then what is the storage we can expect, storage capacity we need, assuming an average post size is 1 KB, which is including text plus metadata. The storage required per day almost 1 TB per day. Okay. And then what is the bandwidth we can expect? Each feed request the fetch 20 post. Okay. So it will be around 5 billion feeds request. We can expect that. Okay. So then the result will be 100 billion post fetched per day. That is the bandwidth we can expect from the system, the server request and response. Okay. So this is the estimation we can consider. Then what is the database designs we can we have to keep. Okay. So the table size, we need a users table, we need a post table, and then we need a followers table. We have likes, comments. So these are the tables we can expect. We need that. Then user tables, it has a user ID, username, email when it's created. These are the fields are needed. And post table, we can keep post ID and user ID, who is the owner of the particular post, and then content and what is the media URL, and then like is there any images, everything has been posted. The image link, image supposed to be published or posted to the S3 bucket, and then that link S3 URI we have to store it in our databases, and then when it was created. Okay. So everything we have to keep it in the post table. And then followers count, so what is a follower ID, and then who is the following ID. Okay. That everything we have to keep it in the who follows who's, so that ID we have to keep it in the followers table. Okay. And then links table, sorry, likes table. So likes table, which post, which user liked that. So that things we have to keep managed. And then comments post, which is like a which post, which user, which comment they added, like the content, that everything we have to keep it in the comment table. So these are the tables, the program like a enough to build the social media system. Okay. And then the API design side. What are the APIs? The basic APIs we need. So which are like creating the post. So when creating the post, what are the ID need, and then user ID need, content need, and then media URL need. This is the one of the API. And then get feed. So get feed, like when this API is comes, what is the user ID, and then what is their limit. When they open the application, this API should be called, and then it will get uh, 20 records in the limit. Then when we scroll, then it will call again next 20 records. It will make the call. Okay. So based on the user ID we are sending to the backend server. Backend server, it will check who are the followers of the particular user. If any of the followers posted any content, or they've posted or not. If they posted it, that details also it should come from this API. And then is there any suggestions? It's That's also backend. We can build some recommendations engine. We can build that recommendation engines based on the user activity, user preference, the profile personalization. It can gather the content from entire system, and then it will provide some suggestions, recommendations, post, and content also it can provide to the user. So that's also we can get it from the feed. And then will be the response, post ID, user ID, content, that we can get it. And then when we are liking the post, user ID, and then post ID, that we can pass it. And then when we are following it, who is the follower, who follow who's which person, so that ID also we can pass. So these are the APIs are enough to build the MVP of like a social media application. Okay. And then high level, what are the components we need to build the entire application. So this mostly we are going to use it AWS related services. Okay. So in API layer, we need API gateway, that will be your interfaces to your customers. So to hit the APIs and get the feed data. Okay. And then your client application will communicate with the API gateway and then make the API calls and get the data. And then we need a Lambda, or we need a EC2 instance. For example, the application, the particular functionalities, it takes less than 15 minutes, we can go with Lambda. If it takes more than 15 minutes, better to use some other computing service, which is ECS or EC2, that we can use it. And then load balancing is generally is for using to distributing the traffic. Okay. So we need a storage layer. So storage layer, RDS, Postgres, MySQL, that we can use it to store structure related data, which is post, users, likes, that we can use it. And then S3 for storing media content, which are images, videos that we can use it. And then DynamoDB for fast access, the followers relationship, the map that we can key value pair that we can keep it in the DynamoDB table. Okay. And then feed generation and ranking. Okay. So that we can use the Kinesis. The Kinesis is a streaming service, process user activity logs in the real time, whatever the activities user is they are doing it. We need a real time suggestions, real time processing. We need that. So better to use real time streaming services that will capture all the events, and then it will send it to the event to the computational data processing service. Data processing service also, it should be uh, process data in real time and give the suggestions and recommendations. And then we can use Lambda for data processing, and then Elastic Cache for pre-computing the data we have. Okay. And then real-time updates, we can use WebSockets. So when there is a post published, we should get the real-time notification in the client, the UI mobile applications. So send real-time notification, we use WebSockets. And the SNS SQS for asynchronous notification also we can use it. So SQS a queue, SNS is a notification system, like which is we can use um the topic we can create it. So based on the topic, the messages and notification, it will be splitted, and then it will be categorized. Okay. So SNS SQS is a kind of queuing service and notification service. Okay. And then analytics, for analytics and monitoring, we can use CloudWatch to monitor our AP performance and logs, everything we can capture that. And we can use Athena for querying the logs and track engagement, we can do it. Okay. So what are the key issues and what are the solutions we can do it? The feed generation strategy. Okay. So there are two ways we can do it. One is fan out on write, which is a push model. When user post, when a user post, we push it to their followers. Pre-computed feed stored in the RDS. Okay. So, and which is a kind of, when user is posted any uh, content, it should be send it to all their followers. Okay. That is like a push model. Okay. Works well for high read, low write systems like a Twitter. Okay. And then fan out on read method, which is a pull model. When user loads their feed, okay, we dynamically fetch the post from their followed users. Okay. Works well for a low read and high write systems. Okay. So hybrid approach is most suggestible, like a use push model for active users, pull model for interactive users, which is really good one. Okay. So, and ranking and personalization. Okay. So the suggestion to use based on their ranking, based on their like a preference, we have to, based on their activity, based on their preference, based on their engagement, we have to rank their news feeds or the social media post feeds. We have to rank that. So better to use a machine learning like a SageMaker, AWS SageMaker, that will help us to build the model. So that will go and check their activities. Okay. Based on that, they will provide some like a content with the ranking, it will provide it. Okay. Recency, engagement, like which is like likes and comments, user interaction, the post past behavior, and what are the trending posts. So that everything we can categorize it, we can rank it based on their user preference. Okay. Then handling hot users, the celebrity accounts. Okay. So store their post separately. Okay. When the users have a lot of followers, how we can maintain their accounts individually. Okay. So what they are suggesting, store their post separately in any cache service, which is like you can use Elastic Cache is Redis we can use, and use CDN CloudFront for fast delivery. Okay. Because they are actually a big account, they have a lots of followers, so may expect every day they will post some content. Okay. So in that case, we can use some cache, and then we can use CDN that will help us to send their contents to all the country users. We can do that. And then real-time engagement, it's one of the important things. We can use WebSockets for real-time likes and comments and count updates. We can use it. And then another one is security perspective. We can use rate limiting. And then the security concerns wise, we can implement a web application firewall to prevent any abuses is going to happen in the API side. And then we can implement IAM roles and cognitive for authentication, implement API gateway rate limiting. Okay, these are the security things we can follow it to keep our application is more secure. Now let's go to the architecture diagram. Okay. So this is the architecture diagram of social media feed. So as we discussed, so the user categories we can see, and then they have their mobile application. Okay, the mobile application will communicate with this edge layer. Okay, so the edge layer, it has Route 53. Okay, and then CloudFront, and then web application firewall it has. Okay, so then once the request is sent to the edge layer, then we have a AP layer here. Okay, here we can see AP gateway, elastic load balancer, auth verification, the cognito we have. So only authorized users can access the specific content. Okay, or based on the user authentication, we can get their details. So we can send the suggested, the recommendation things, we can send it to them. Okay, so in the elastic load balancer, it will communicate with the EC2 or ECS computing service, where whatever the logic, application logic side we have. So here we can, if the functionality is taking more than 15 minutes, we can go with the computing service EC2 ECS. We can use it. If the functionality is taking less than 15 minutes, we can use Lambda. We can use it. So feed related things, we can use Lambda, and other optional other logics we can keep it in the EC2. Okay, and then we have a database side we have. Okay, so database. We discussed about three different storages. One is relational databases for storing users, post, and likes, and another one is DynamoDB for followers count. Another one is S3 for object storage for media details. Okay, so and then we have some real-time engagement systems we have. So whatever the feeds and everything, it will be sent it to the SNS will send it to the SQS, and then whatever the process happen, that things is sent it to the WebSocket. Okay, so the WebSocket, it can connect it with the mobile application. Okay, it will update the changes into the mobile application in client side in real time. Okay, so that we can do it, and then we have monitoring service as well, that will help us to monitor and collect the logs and system performance, everything we can do it. So using CloudWatch, we can collect the logs and performance, everything we can capture. And then if we want to query, do some operation in the media thing, we can use Athena. So it will directly write the queries in the S3 files. Okay. And then next we have feed engine, which is a recommendation engine system. Okay. So here we can see Kinesis stream, based on whatever user activities they are doing it will be sent it to the Kinesis stream. And then we have a Lambda to process that the data. And then we can store the pre-computed data into the cache, so we can easily access it. And then with low latency. And then we have a SageMaker service for ML ranking. Okay. For ML ranking, we can use SageMaker, the ranking model, we can use it. So this is the category for recommendation system, ranking and personalization, we can use it. So this is all about like building and services about of social media feed system. Okay, so I think that's it all about this session. So we will discuss about in new use cases in upcoming session. Yeah, thank you everyone.